Hi, welcome back to the Network Plus Certification video series. I'm Mike Redmond, Master Trainer, here to help guide you through your successful journey of becoming a Network Plus certified technician. We're going to walk through a wide variety of topics, starting with basic network concepts all the way through network management and security. In this segment, we're going to discuss advanced networking devices. We'll discuss client-server and peer-to-peer technologies, describe the features and functions of VPNs, show you how to configure and deploy VLANs, and explain to you how to implement some advanced switch features. So now that we've covered the simple devices that each work at one or the other of the OSI layers, now we're going to take a look at some of the advanced network devices. These devices are what we call multi-layer devices. For instance, your home router is really a multi-layer switch. CompTIA's logical network topologies break these down the way network systems are organized, whether it's client-server or peer-to-peer or VLANs or VPNs. First, we'll take a look at logical network topologies. The logical network topology really goes beyond the physical or signaling topologies. It's more a software architecture model. Roles that computers play in these networks are broken out into either being servers or clients. In a server-client topology, you're going to be dealing with a dedicated server and dedicated clients. The earliest network models, as a matter of fact, were client-server topologies. Next would be peer-to-peer topologies. For instance, the early versions of Windows, like Windows 98, were designed solely around peer-to-peer topologies. Very little concern given to security. Most of them, there weren't even user accounts. You had basically two permission sets, read-only or full control. However, today's peer-to-peer networks, there is much more robust security. You have individual users' accounts and much more advanced permissions down to granular options between read, read-write execute, full control, and so on. So understand, with both peer-to-peer and client-server, they're linked to individual applications, like your email client and your email server. For instance, the client that you're probably using would be Microsoft Outlook, whereas the server that holds your email would be the Microsoft Exchange server. Another example of the applications that we use are peer-to-peer applications. They act as both client and server, for instance, with file sharing technology like BitTorrent. Next, you have VPNs, or virtual private networks. A virtual private network is essentially a private network over the internet. It's an alternative to expensive dedicated lease lines, making connections via encrypted tunnels. Data is encrypted and decrypted at each endpoint, and connecting computers must have the same network ID to reside on the network. There are two tunneling protocols with VPNs, either point-to-point tunneling protocol, or PPTP, or the L2TP, or Layer 2 tunneling protocol. So with PPTP, the point-to-point tunneling protocol, the more advanced version of PPP, one endpoint is the client. The other is the routing and remote access server, or the RAS. Clients use a virtual NIC that acquires a DHCP address from the RAS. The clients then connect to the RAS via the PPTP and create a tunnel through the internet. Next is the Layer 2 tunneling protocol, developed by Cisco and has all the good features of PPTP, plus a little added support to run on most any type of connection. However, they have moved the endpoint on the local LAN. With this, you're going to use a VPN concentrator as your endpoint, and then your clients will connect via the concentrator to your internal LAN. However, it's important to note that L2TP has no authentication or encryption. That's why you'll normally see it coupled with IPsec. So technically, I guess it should be called L2TP IPsec VPN. This is the protocol that's connecting your clients to the LAN, or possibly even from LAN to LAN. This is what makes it possible to have site-to-site VPNs. They're used to connect two LANs separated by a WAN or a cloud. They're using a VPN concentrator, so knowing this, you know that they're using L2TP, or the Layer 2 tunneling protocol. It is a bit slower, however, it is less expensive than dedicated lease lines to accomplish the same end goal. Here's a look at a Cisco VPN concentrator, or otherwise known as an integrated services router. Also, coupled in with VPNs, you have SSL. VPNs use SSL to work. SSL is the transport layer technology that makes it all flow. It doesn't require any special client or software. Your clients at this point are connecting using a web browser. Then the traffic itself is secured via an SSL tunnel. The two most common types are an SSL Portal and the SSL Tunnel VPN. SSL Portal VPNs, they provide for client access VPN and is presented with a secure web page. You're able to access anything on that page, such as email or data or some hyperlinks as well. With SSL Tunnel VPNs, the client browser runs an active control, such as Java or Flash, that enables much greater access to VPN-connected networks. It creates a more typical client-to-site connection than the SSL Portal VPN does. However, it requires that your user have sufficient permissions to run active browser controls. However, there are some alternatives to the point-to-point tunneling protocol and L2TP and SSL for that matter. Although the majority of VPNs are going to use these technologies, there are some competing technologies like OpenVPN using Secure Shell or SSH, or just using pure IPsec using IPsec tunneling. Next, we have switch management. So managed switches require a little bit of extra programming to handle switching and security, as well as some of the other functions that we ask of them. You're going to connect to these switches via a serial interface and a virtual terminal program to connect to the command line interface. Then, to get the switch on the network, you'll use that virtual terminal to connect to the command line interface via SSH session. However, a lot of the more modern managed switches provide a web interface for connectivity. Next, let's take a look at VLANs. So a VLAN is a virtual local area network. It's used by all but the smallest LANs. Most other networks are fairly complex. They have to deal with multiple connections like remote incoming connections and public web servers and email servers and wireless networks and strings of connected switches, as well as a tremendous amount of traffic. This all brings with it some very specific security issues. So VLANs have become one of the accepted solutions. VLANs separate networks with multiple switches. They segment our networks. They break up the broadcast domains. They do this via trunking. Trunking connects the VLANs on separate switches. You'll have one dedicated port on each switch that is identified as the trunk port. On Cisco devices, this is called the interswitch link. So again, on modern networks, the implementation of VLANs, you're going to see the IEEE standard 802.1q. This is what's used to connect switches from multiple sources. To configure a VLAN, you'll need to connect to the web server on the switch. This is the most common connection type with Cisco Catalyst models. So you'll remember I told you that switches operate at layer 2. They use MAC addresses. However, managed switches use layer 3. They're using IP addresses. This is how you're going to define your VLANs. They assign MAC addresses or ports to a particular VLAN. And then through the VLAN trunking protocol, you'll see this on large networks with many VLANs that would require a lot of manual updates. The VTP, while proprietary to Cisco, it automates updating multiple VLAN switches. It goes through 3 different states: server, client, and then transparent. Updating configuration of the server switch updates all other switches that are in client state in minutes. If, however, you have switches operating in transparent state, they will not receive any updates. Next, we'll talk about inter-VLAN routing. So each VLAN is its own separate broadcast domain. You typically need a router to communicate between different layer 3 devices. This is a limitation with physical routers. So some switches can do what is identified as inter-VLAN routing. For instance, the Cisco 3550 supports VLANs and then virtual routers through additional modules. This allows the switch to work at both layer 2 and layer 3. So with these multi-layer switches and inter-VLAN routing, on layer 2 is where the switching is actually happening. The ports don't have an IP address. It's the router module with each port that must have an IP address. And if you're using a multi-layer switch like a Cisco 3550, the multi-layer ports can be configured to operate in either mode, either with layer 2 or with layer 3. Next is load balancing. Load balancing takes many servers and makes it look like one. This is how we create a server cluster. This way, when we have many requests, it's distributed evenly amongst all the servers. Now, there are many load balancing methods. And it's extremely common to use advanced network devices to get this done. Next is DNS load balancing. It is probably the oldest and most common method of load balancing itself. Each server has its own IP address. There are multiple A records for one FQDN, or fully qualified domain name. The DNS server will then cycle through those A records. For instance, to accomplish this in Windows DNS, you need to enable round robin. On a bind DNS server, you'll find a few more features. However, it will require you to have multiple DNS servers. So when using multilayer or a content switch like a proxy, you're going to run into a client cache problem, especially with DNS load balancing. So you're going to have to hide the web servers behind a single IP address. Again, you'll need a special multilayer switch. However, this time that multilayer switch will be operating on layers 3 and 4. So the router portion operating at layer 3 will be performing NAT and port forwarding. And the layer 4 is going to handle the queries that are hidden behind the web server. So a content switch for load balancing. So using a content switch for load balancing, now we've moved up another couple of layers. This works at layer 7, the application layer. It works with, for instance, web servers. It reads incoming HTTP and HTTPS requests and then handles SSL certificates and cookies. This takes the workload off of your web server, and it then passes those cookies to your web browser, acting as an intermediary. This is a good way to QoS our traffic or provide quality of service. It controls the bandwidth usage and can enforce the rules-based policies to give higher priority to some traffic over others. This is called traffic shaping. Traffic shaping is a bandwidth management tool. You're controlling the flow of packets in and out. It guarantees a certain amount of bandwidth or latency to some at the expense of others. Next, we'll talk about network intrusion or network protection devices. We'll talk about intrusion protection and intrusion detection, as well as port mirroring, proxy serving, and port authentication. When it comes to intrusion detection and intrusion prevention, there are a couple terms that you need to know and understand. With intrusion detection systems, or IDSs, they come in two different flavors, either a network-based IDS or a host-based IDS. However, both of them are doing the same thing. They're reporting back on alerts that the administrators have set. These are passive devices. Unlike intrusion protection systems, or IPSs, these add the capability to automatically react to an attack. It can block incoming packets on the fly. These are active devices. Next is port mirroring. This mirrors data from ports to a single port. It works a whole lot like a configurable promiscuous mode. This allows the inspection of traffic to and from certain computers. And proxy serving. A proxy server simply sits between clients and external servers. It intercepts requests from clients, if you will. It makes requests on your client's behalf. So effectively, you've disabled your client's use of DNS. It will use the proxy server instead of DNS. And finally, port authentication. Authentication at the point of connection. This is critical, for instance, for AAA authentication. We talked about these when we looked at Radius, TACX Plus, and 802.1x. Now, don't get confused. CompTIA drops the plus symbol when talking about TACX Plus. It's the same thing. Many switches and WAPs will support AAA services and port authentication. Well, there you have it. Pretty simple, right? I know, it can be a lot of information coming at you all at once, but don't worry. I'm here to guide you every step of the way. You can do this. Just remember, study hard, lots of practice questions, and you will succeed. You will become a Network Plus certified technician. I'll see you next time.